So we'll do cd front end, and then again we do npm install. All right, once that is done, we'll do npm run dev. And now our front end is running on port, this port. So this is where we got so far last time. We were not able to get the calc integration working. We will get back to that in our next class, because I think for us to do that and understand it in details, we need the Docker to be working. So so far, this is what we've learned so far. Let me just zoom in. All that. So mosesmbadi.com. So what we've done is we have the front end and we have the API. So in some cases, this is your entire stack. And again, let's use a real world, let's use a more complex example. Let's look at the platform somastories.app. Somastories.app is powered by a couple of things. It's not just front end API and whatnot. We have, let me just resize everything here. So that is the front end, that is the back end. Back end is API. And then we have a service running on Flask API. And Flask is basically Python, like so. Our main API is running in Node.js, but it's using a framework called Express.js. So basically, it's JavaScript. So this is JavaScript. Our front end also is JavaScript. JavaScript. So I can just put this at the bottom here, so that we know the languages we are working with. And again, the API is using JavaScript. Flask is using Python, so we can just replace that so that we have uniformity. So this is using Python. Now, this is not everything. Because in any application, you want to have something called caching. And in our case, caching is handled by another tool called Redis. So we can just say this is Redis. And which language is Redis written in? I have no idea. Let me just quickly Google that. Redis language. So let's see. Okay, so it's written in C. So Redis is written in C. And then that is not all, because we need to run some background tasks. Okay, we need to run maybe data cleaning services, and I'll show you why we need a background service. So our background service is using BoolMQ. I need to check what BoolMQ is written in. I think it's written in JavaScript. BoolMQ language. Okay, so it's written in TypeScript. So our BoolMQ is written in TypeScript. All right. So this is the entire stack that powers Soma Stories. Of course, we have the mobile app, and the mobile app is written in what we call Flutter. Flutter is built with Dart. Dart is another programming language. And between you and I do not know how to write Dart code, but I know how to write Flutter code, which is interesting. So this is the entire stack that powers Soma Stories. Now, before I continue, because I want us to move together, do you have any questions so far, given what I've just explained? It's for background jobs. Okay, I will explain. Let's just go through how the process basically looks like. So if somebody, we have our front end. Let's say, for example, we have our mobile application. So a user wants to upload a story. Let me just resize that. Let's bring this at the top here. So a user wants to upload a story, and this is very important, especially understanding how data flows in any application helps you very fast understand the architecture that was used to build that application. So what information will the user send to the backend? They will send the story payload. So this is the story payload. And in this story payload, we have a couple of things. Number one, we have the story title. So we have the title, we have the content, we have the thumbnail, which will be used as the preview image. Thumbnail, we have the token amount, how much the story will be worth, and we will have the tags. So a user has to select what tags they want the stories to have. As we look at the data in this format, it's also important for us to have a look at what that looks like in the client interface. So if I click create story right now, this is what I'm talking about. So we have the tags, which is required, by the way. You have to attach a tag. We have the title, we have the story content, we have the cover image, and we have the token amount. So this is what it looks like in the front end. Now, this information the user sends to the backend through the mobile app. Of course, the user types in the mobile app, and the information goes to the API. So the API is what is hit first in this case. So what will the API does? Because the API also has other things it's handling. For example, we have other people reading stories, we have other people trying to top up their accounts, we have other people trying to do all sorts of things. So we cannot just pause everything else and focus on this story upload, because we need to check, is the words in the right amount? Is it plagiarized? Is the person posting nudity? Is the person posting what? So the API will schedule that task. It will call Redis and tell Redis, hey, I want you to store this information so that BullMQ can process. So BullMQ will sit somewhere right here. So what will happen is Redis will just store the queues it needs to run, because remember, it's not one person trying to upload a story. So that is Jack trying to upload a story. We also have, maybe let's say, John right here trying to upload a story. John is also communicating using the mobile app, right? Something that looks like this. And the information goes to the API and so on and so forth. So right now, Redis will have two things in queue that BullMQ is supposed to process. So it will have a story from John, it will have a story from Jack. So right here we have a story from John and we have a story from Jack. These two stories need to be processed. But remember, it's Jack who posted the story. Jack is the first person who posted the story. So Redis will send Jack's story to BullMQ. What does BullMQ do? So BullMQ is responsible for check nudity. It will check nudity. It will check plagiarism. It will also check profanity. Is it profanity? Okay. Nudity, plagiarism, appropriate tag or correct tag. Because if you are posting a story that is NSF is like not safe for work, so something explicit, you need to use the correct tag. You need to set that. If I come to my tags right here and I look at the tags available, I can see I have this sexual content. So if my story has something that is, explicit, I have to specify. So BullMQ is responsible of doing that. So while it's running all this, it might even take a second. We cannot pause everything. We tell the API, oh, you do this as BullMQ is processing, because again, it's not only these two users trying to access your application. So we may have somebody else on the desktop right here, and they are just reading stories. They are not doing anything else. So here we may have this person. Can't do my thing. And this person is just reading a story. So this person has sent a GET request to the server. So this is a GET request, and they are getting the same information. And we can just add the methods here. So this is GET. I can use a different color to, yes. So they are doing a GET request. This person is doing a POST request, POST. This other person is doing a POST request. You do understand what GET, POST, these verbs are, correct? Yes. So while this person is trying to get a story, we have to be fast because we want to create a good impression. Human beings are very impatient. Okay, you don't want to put a user there for 1 second because API is busy handling whatever issues it's handling. So this person has to get that story fast, and the API in this case will not even, okay, it will talk to the Redis cache, but we'll look at that scenario in a second. So I even forgot to add here a database because we also have a database. So let's just get a database here. We have our database. So this is where all the stories are. So when the API receives that request, which is a GET request, it doesn't need to bother BullMQ, or it doesn't need to bother Redis at this point. All it will do, it will go and get that story from the database and send that story to this user. All right. So this falls under what we call async systems that can perform multiple tasks at the same time without you even noticing. So what happens when BullMQ is done? When BullMQ is done, it will communicate with the API and tell it, hey, I'm done. This story is okay. You can go ahead and save it to the database. So what API will do, it will again take the story content and save it to the database. Now, it's important for you to understand this process takes less than 2 seconds. But